Hi, and welcome to the Chapter 5 vocabulary review video for Chem 100. The first word, activation energy. So this chapter is really all about chemical reactions and how fast they go and some of the different types of chemical reactions. So activation energy is the amount of energy that a reaction needs to get going. So just like, a ball will roll down a hill, but you got to give it a little push first. All right, same with reactions. They will go, but you got to give them a little push first. Or like a fire will burn, but you got to start it with a spark. So that's the activation energy. It's the amount of energy you have to put in to get the reaction to go. And different reactions have different activation energies. The higher the activation energy, the slower the reaction. Active site is part of an enzyme. So an enzyme is also on your word list. An enzyme is a protein that acts as a catalyst. So enzyme, catalyst, and active site I'm addressing all at once. A catalyst is anything that speeds up a chemical reaction. And in like chemistry labs, a lot of times the catalyst is some kind of a metal. But in biological systems like cells, the catalyst is an enzyme. So it's a protein that binds to the reactants of the chemical reaction and speeds up the chemical reaction. The site on the protein where they bind and where that reaction takes place is called the active site. Biochemical reactions are any reactions that occur in a living thing. So within cells, all the chemistry that goes on in your cells is biochemistry. Chemical equilibrium is a state that can be reached by a chemical reaction that is reversible. So a reaction that can go in the forward direction and the reverse direction. And chemical equilibrium is when those two rates, the rate of the forward reaction and the rate of the reverse reaction, are the same. So it has nothing to do with levels of reactants and products. It has everything to do with the rates of the forward and reverse reactions being the same. So rate being a key word in that definition. Combustion reactions. Now we'll talk about some specific types of reactions. Combustion is specifically when you have an organic substance, something containing carbon, and oxygen, and a little bit of activation energy, and the reaction forms, the products are carbon dioxide, water, and heat. Always. So the oxygen, carbon dioxide, water, and heat always stay the same. The thing that changes is what material you're combusting, so what organic material. A condensation reaction is also known as a dehydration reaction. Both words are on the list. And these are reactions where water is formed as a product. So basically, two hydrogens and an oxygen are removed from the reactants and end up as water as a product. A decomposition reaction is any reaction where you're starting with one reactant and you get two products or more. So something is getting broken down into smaller pieces. Where are we on this? Endergonic or endothermic reactions are ones that take in heat. Endo means within. So they absorb heat. And if we're looking at energy diagrams, all right, they are ones that they have an uphill energy diagram because the energy of the products is higher than that of the reactants. The opposite is an exergonic or exothermic reaction, and those give off heat. So they feel hot to the touch, and they have an overall downhill energy curve because they are losing heat. There's less energy in the products than there are in the reactants. An exchange reaction is one where you have, like if you have an couple of ionic compounds and they react with each other, so you have like one ionic compound that has two ions and another, and then they swap partners. Can't do it with my fingers here. So there's single exchange and double exchange reactions, but these are ones where you have two molecules come together and they basically switch parts, do a little part swap. Let's see, next we have the heat of reaction. So when we talk about endothermic and exothermic reactions, we're talking about the change of heat that occurs, the change of heat that occurs from going to reactants to products. and it can be positive or negative. If it's a positive heat of reaction, then we're talking about an endothermic reaction. If it's a negative heat of reaction, we're talking exothermic. So those are other ways to identify endothermic and exothermic reactions. So the heat of reaction is just the change in energy that occurs during a chemical reaction. An irreversible reaction is one that only goes one way, so it goes in the forward direction, and we say irreversible reactions go to completion. So all of the reactant reacts and forms product, and you can't take that product and turn it back into reactant. Oxidation is another type of reaction. Oxidation and reduction, they go together. Sometimes we just call them redox reactions. Oxidation is loss of electrons. Reduction is gain of electrons. The mnemonic for that is oil rig. Oxidation is loss. Reduction is gain. So redox reactions, oxidation and reduction, are all about gaining and losing electrons. A phosphorylation reaction is one that involves moving a phosphate group, PO4, from one molecule to another. And this happens a lot in biology. A lot of enzymes need phosphate groups to turn them on or off. Your DNA gets phosphorylated, so lots of things. These phosphate groups really are kind of like on-off switches for a lot of things. So they're very common reactions in cells, phosphorylation reactions. The rate of a reaction is the speed of the reaction. It's how much product is produced per some amount of time. And there are different things we'll talk about that increase or decrease the rate of a reaction. Reaction kinetics is the study of reaction rates. So the field of kinetics studies how fast reactions are, how to make them faster, how to make them slower, etc. A reversible reaction is one that can go forward and reverse. You can take reactants and make products, and those products can recombine or whatever to form reactants. A synthesis reaction is the opposite of a decomposition reaction. So that's one where you're taking like two things as reactants and then you get one product. So you're combining two things into one. They're building reactions. Synthesis reactions are building, decomposition reactions are breaking down. And then lastly, thermodynamics is the study of the heat exchange that occurs in chemical reactions. So discovering whether something is endothermic or exothermic and what is the heat of reaction is all under the field of thermodynamics. Hope that helped.